Suppose you have a function y with respect to u, and the variable u is a function of another variable x. Then you can apply chain rules such that the derivative of y with respect to x would be equals to derivative of y, which is a function of u with respect to u, times derivative of u, which is a function of x with respect to x. Product rule. With the help of product rule, what you can do is you can take the derivatives of two different functions, multiply together. So let's say you have f, which is a function of x, and g, which is also a function of x. Then you can take derivative of the multiplication with respect to x, and the product rule says is g, your derivative of function f with respect to x, plus f, the derivative of g with respect to x. Quotient rule. With the help of quotient rule, we can take a derivative of two functions, let's say f and g, with respect of the same variable x when they are divided, or when they are being divided with each other. So let's say if we need to take a derivative of function f divided by g in respect to x, then with the help of quotient rule, the denominator g, we take the derivative of f with respect to x minus numerator f, derivative of a denominator function with respect to x divided by the square of denominator. Example number 1. Let's say we have a function f with respect to x, which is equals to x squared minus 2 to the power 6. Then what we can assume is, let us assume the function x squared minus 2 be u 2. Then your f function with respect to u would be u to the power 6, where your u is the function of variable x and is equals to x squared minus 2. Then applying chain rules, what you can do is your function df with respect to dx would be df with respect to u with respect to u times du, which is the function of variable x with respect to x. So the dfu would be du to the power 6 divided by du times dx squared minus 2 divided by dx. So your first function would be 6 u to the power 6 minus 1 dx squared minus 2 by dx. Let's just simplify this one, and for our formula that we went through in our last video, we can say derivative of x squared respect to x minus derivative of 2 respect to x. So it would be 6 u to the power 5 times 2x 2 minus 1 minus 0. Our final answer would be 6 times x squared minus 2 to the power 5 times 2 to the power x. Or if you want to simplify, you can just say 12x x squared minus 2 to the power 5. So that's how we apply chain rule. Example number 2. Say we have a function fx which is equals to x plus 2 times x squared minus 5. So you can see there's two functions. Let's say this one's fx and the another function is g, which is also with respect to the same variable x. Then we can apply product rule to this particular function. So what product rule says is if we have to take a derivative of f times g with respect to the same variable x, then your product rule would be g times df with respect to x plus f times dg with respect to x. So substituting the values of g and f, we have g equals to x squared minus 5 d with respect to x plus 2 by dx plus x plus 2 dx squared minus 5 by dx. Simplifying that one would be equals to x squared minus 5 dx plus 2 by dx. If you want to recall, please go back to our previous video, but this would simply be dx by dx plus d2 by dx plus your x plus 2 times, similarly this one would be dx squared by dx minus d5 by d5. So it would be x squared minus 5 dx by dx would be 1. This would be 0 plus x plus 2 dx squared by dx would be 2x, and the derivative of constant would be 0. So if you want to simplify it more, you can just put in like x squared minus 5 plus 2x x plus 2, and if you want to simplify it more, you can do it, but I'll just put it this way. So this is how we apply product rule. Example number 3. Let's say we have to find the derivative of function 3 minus 2x squared divided by 3 plus 6x cubed. So what we can say here is your numerator function be fx, which is equals to 3 minus 2x cubed, and the denominator function be gx, which is equals to 3 plus 6x cubed. Then we can easily apply quotient rule, where it says if we need to find the derivative of f by g with respect to x, then it will be equal to g times df by dx minus f times dg by dx divided by g squared. So let's apply that rule here. We have our gx 3 plus 6x squared will be 3 plus 6x cubed, sorry, and then d 3 minus 2x cubed divided by dx minus your f would be 3 minus 2x cubed d 3 plus 6x cubed divided by dx, the whole divided by the whole square of function gx, which is 3 plus 6x cubed square. Now it's just a matter of simplifying. Your d3 minus 2x squared would be the derivative of constant will be 0, so it will be minus 6x to the power 3 minus 1 minus 3 minus 2x cubed. The derivative of the constant 3 would be 0, so 3 would come down and multiply with x, would be 18x to the power 3 minus 1, which is square, divided by 3 plus 6x cubed whole square. So now if you want to simplify more, you can do the simplification, which is minus 6x squared times 3 plus 6x cubed whole minus 18x squared 3 minus 2x cubed divided by 3 plus 6x cubed whole square. Last question is a challenge exercise for you guys to solve. Please solve this basic function 2 plus x to the power 5 times 2 minus x to the power 4 with respect to x. And if you guys are able to solve the problem, please comment your answers below and I'll let you know what's the right answers.